grab some random side, animal chemistry.
Look at
Look, take the derivative of this right now.
Alright. So, we're going to do, so if you look back there, it's kind of like the summary of the rest of the year. We did a one sample significance test. That was the last chapter. So there's kind of a bunch of different ways I could go in order, but I could do two sample mean next, but I'm going to jump down to one proportion or one sample Z. So we're going to do one sample and then one proportion, so differences, means, and proportions. And then we'll probably jump back to two sample mean and then jump to two sample proportion. For the retake, for the corrections, it's a little different than I typically do. I'm going to make this test, if you do better on this test, I'll replace your last test score with this test. Yeah, I'm not doing that like the whole way out, but I'm going to do it like in little bits and pieces. So, if you got...
Wait, if we do worse on the second test...
Let me explain it.
Okay.
Like if you got a 60 on the last test, and you have all your homework in. If you don't have all your homework in, none of this matters for you. You just get what you get. But if you have all your homework in, the next test will test the new stuff and also the stuff we just did. So if you can prove to me at that point that you know the stuff that we just did, then I'll give you the credit for it. I'll go back and like replace it. So if you got a 60 on this one, you get an 80 on the next one, and you have all your homework in, I'll just go back here and make this an 80. If you got an 80 on this one and a 60 on the next one, I'm not going to go back and make it a 60. Like this thing cannot hurt you; it can only help you. So if you have all your homework in, and if you do better on this upcoming test, I will apply that score to the previous test also. So that's like the corrections for this portion. Yeah.
So now, what if we got like a 90 on the following test?
On the third test?
Yeah.
Right now, this is a two-test game.
Oh, so,
It's possible that'll extend, but right now we're doing two, and we'll see where we go. So don't rely on like something down the road. It may or may not happen. I know we talked about that, but I'm starting with two. Yeah. Questions on that? That seem reasonable to you guys?
yeah.
Fair enough. Okay. All right. So we're doing one prop Z test. So I gave you the notes. This is basically the template, but I'll write it out too. Do you want to do an example and then write out the template, or do you want to do a template and then the example? Example first. Okay. That's what people usually say. Well, as long as we get pile taken care of. All right. One proportion Z test. So Z means normal. So if you remember, like when we were in means, we were doing the T distribution, which is like a little more spread out, bigger variance, wider, because we're estimating the population standard deviation. This is normal, so we don't have to estimate anything. We know everything we need to know. So the first thing you have to do every time you see a problem now is decide, are we working in means or proportions? If it's means, you do T. If it's proportions, you do Z, which is normal. Oh, we're doing an example, aren't we? All right, so let's do number one. MHS claims 80% of graduates go to college. We think that that might be less. So we take our sample. Okay, so in this case, normally, like in the last one, we would say mu equals. Now we're going to say P equals. So P equals the population proportion. That's the equivalent of population mean. Like you have to say those two words. You have to say population. You have to say proportion. And then put it in context. So like of MHS students that go to college. HO would be P equals 0.8. That's their claim. What would HA be? P is less than 0.8. So that's, I mean, it's very similar to the mean stuff, right? Just doing P instead of mu. So like the whole process should be pretty solid, hopefully. And then we're just changing a couple things. So check your conditions. In number 1, assume SRS because they didn't tell us it was, so we have to assume it. The next thing we're going to write in this one, and I'll go through like options with you, like on the template, but in this case we would say treat each student as independent. So that means like Athena going to college or not has no impact on Joel going to college or not, which has no impact on whether Nick goes to college or not. You guys are all like separate beings. And then the last one is you need to show me that n times p is greater than or equal to 10, and n times q is greater than or equal to 10. This is basically the sample size, like they're making sure you have a big enough sample size. So in our problem here, number 1, what's n? 50. What's p? 0.8. Is 40 bigger than 10? Then we're good. Same thing over here. So 50 is n still. What's q? 0.2. That is 10. We're still good because it's greater than or equal to. So you can't just write like the NP is greater than or equal to 10. You have to prove it to them. You have to be like, here's n and here's p. That is bigger than 10. All right, the math box. So what's the very first formula we wrote in the last one? Test statistic. This still applies. Test statistic equals statistic minus parameter over standard deviation of statistic. Is your test statistic in this case T or Z? It's Z. This is normal, so this is Z-scores. This is like chapter 2, normal CDF, and all that stuff. So with means, we can't use normal, we can't use Z, but with proportions, we can. So Z equals what? How do I represent the statistic of a proportion? P what? P hat? Minus what's the parameter for a proportion? P. What's the standard deviation of a sample proportion? Everybody remember that? Square root of PQ over N. Alright, so in our problem, what is P hat? No, that's P. P hat is the sample proportion, right? So in this problem, what's the sample proportion?
35.
Yeah, so what I would do, you don't have to do this, it isn't like part of what's required, but I would go up here and go, okay, P hat equals 35 out of 50, which is 0.7. You guys see where I'm getting this from? We took a sample of 50 students, 35 of them went to college. So this is my sample. So then down here, I'm going to go 0.7 minus 0.8. That will make my z-score negative. Why does it make sense that my z-score would be negative? Because we're below the mean, right? So the square root of 0.8 times 0.2 divided by 50. Get your calculators out. You don't have to type that in. There's your calculator to do all the stuff for you too. You can type that into it, but you don't have to. So stat tests, now here you will never use z-test. Z-test is stupid. It's like a redundant, you're testing something you already have information for. We will use one prop Z test though. I don't like the way the calculator sets it up like that, but oddly they didn't ask me what I thought. So one prop Z test. Now this is a little different than what you might expect. So P sub 0 is like the P that goes with H naught. So that's 0.8. But then you never type 0.7 in. You're typing in like the fraction. So the X is like the number of people that went to college. The N is the number of people in your sample. So you're basically writing a fraction there. Like if you think about it as though it's like this. I don't know why I just in a box with a light in it. But I'm trying to get you to say, okay, we know 35 out of 50 people went to college, so you're basically writing that fraction there just in 2 lines. That makes sense what I'm trying to
Yeah.
get across.
Yeah. The number of people that did what we want versus the number of people we interviewed.
Yeah, but I know this is going to happen. Someone's going to type 0.7 there and be like, what's that? I'm going to put 50 here and it won't work. It's going to happen. We'll fix it. It's not a big deal. It's the first time you've seen it. But try to remember that fraction is what goes there. Do we want not equal to, less than, or greater than? Less than. And then you can hit calculate or draw. End up like it should look pretty familiar to you. It tells you p hat, just in case you didn't already know it. And then I'm going to write down, so z is negative 1.77. P-value, I can't just write it. I have to show how I would get it if the calculator didn't run the test for me. So with means, we did TCDF. Proportions, we're going to do... Nope. What? So normal means Z. We're in Z's, right? Z means normal, normal means Z. So we can't use TCDF, we're going to use... It would be ZCDF, I guess, but that's not what they call it. It's called normal CDF. So when you are in proportions and Z's and normal all go together. So this would be normal CDF. It was a less than test, so that means this is like the high end, the bigger number. So negative 999. And then one nice thing here is you don't need the degrees of freedom. Still going to draw it. So in the middle, P equals 0.8. Over here somewhere, P hat equals 0.7. That 0.038 is the size of that shaded region. And that's my z-scores. What?
This is normal CDF?
Yeah.
Okay, because in my calculator, it still tries to have me put in mu and standard deviation.
Did you do t-test?
I did normal CDF.
Like you went to Mars and like found normal CDF
Yeah.
there.
Oh! Leave the mean and standard deviation as 0 and 1. That's like the default. But you don't need to do that. Like if you ran the test, it gave you the... Okay, you're just like checking it a different way. Okay. What's alpha? 0.01. Made it lower in this one. Alright, so since p-value is greater than alpha, so 0.038 is greater than 0.01, reject or fail to reject? Fail to reject. H naught. There is not enough evidence to support HA. So you didn't convince me that HA was the better option. Meaning, you do not think less than 80% of MHS students go to college. Cody just dropped something in there. like you got to practice that conclusion wording a lot still. Some of you a lot, some of you a little, some not at all. But the thought process is the same. We're going to reject H naught because we think HA is good, or we're not going to reject H naught because I'm not like impressed by HA. Questions on here anyway? Wording about this, anything? Can I move on, or are people still ready?
Yeah, I'm still right.
Holly, you good? Okay.
So we're gonna do the template.
Yeah, so let's do a template now. So this would be like your kind of like your cheat sheet. So one proportion Z test. What does Z mean? Normal. Kyle, where are you going?
Can we write cross?
You had a choice of what times to give blood. Did you? Did you not?
Yeah, I guess.
Smack dab in the middle of AP, huh?
I have a lot of AP.
Yeah, I think all his classes are fees.
You're in senior way, right?
No.
You're not?
I am.
Let's run through your schedule. What do you got?
Okay, I got choir first and second hour. We got festival next week, so she'd kill me.
Oh yeah, she killed me.
really would.
Okay,
Yeah.
that's fair.
And then I got AP lit, then lunch, this, and then online class. So giving blood is going to flow into my online class. And then I got
I see what you did there with the word flow.
Yeah, I like that.
Blood. That's nice.
Yeah, yeah. And then I got AP Calc.
That teacher's a dick. He would kill
Yeah,
you.
yeah. When I signed up, he specifically said, don't skip it. Yeah, we got the gateway. So, and then I got physics, and I have a test tomorrow.
Alright.
Life sucks.
Yeah, for real.
Why would you choose that?
Yeah.
I don't have to do big red talks.
Because he's not doing it exactly.
Yeah.
Soul has to go too, though.
I like all file.
Yeah, I don't think
So, can we just write?
because Alexis was like,
It's like
You got
it's
it.
like that big round right there.
Bye, Ben.
That's
we're not gonna take acid if they can't take it. I don't know if you're talking about.
Your blood is acid? Is that what you're saying?
He
Yeah.
tried to me that O negative blood isn't the best type of blood to donate, but it definitely physically works on it.
Which one works on everyone?
O negative.
That's like universal donor.
Yes.
Is that what you are?
My blood test.
That's what you are?
Yeah.
That's the opposite of acid. That's like gold.
That's what I'm saying.
He's refusing to give us the needy.
I don't know what
Yeah,
it's
maybe.
I don't know what I am.
I don't either. I don't have a clue.
Whatever you say, I am.
Yeah, how do you know? How many people in here know their blood type? I have no idea. How do you know?
That's something we said.
I like I knew it.
Yeah.
Alright.
What's your next above population?
What's where?
Right above population.
Of?
Oh.
So SRS standard assumes, same as the last one. Each blank is independent, so like when we just said each student is independent or whatever, so each blank is independent. And or, because sometimes you'd be able to do both of these, sometimes there just won't be enough information. And is less than 10% of the population. Those are both getting at independence. We'll get into that more as we go, and then this is what we just did, that NP is greater than equal to 10, and NQ is greater than equal to 10.
You have to write both. If they're both right, you have to write both.
If they're both there, you want to write them both. But oftentimes, like, you'll only be able to write one of them. Yeah.
Is it always going to be 10?
Yes.
Okay,
So there's no, what's missing? What was there in the last one that's not here?
Population standard deviation.
Population standard deviation unknown is not there. And what else?
No staying
Yeah, so the T distribution was basically getting at like there has to be a big enough sample. Like either the population's normal or we got a large sample or we can do the skew outliers thing. But this is also getting at like I need a big sample. So if n is tiny, your NP is not going to be bigger than, like if you have a sample size of 10, this, I don't care what P is, you're not going to be able to make this work. So this is basically like the sample size qualification. It just looks a little different with proportions than it does with means. Alright.
So you don't need both NP and NQ?
No, you need both. And. Alright, so test statistic equals statistic. Same exact thing as before. Minus parameter over standard deviation of statistic. Is the test statistic in this case T or Z? Z. Why? Proportions are always Z. So that's, just remember that. Proportions. So it's P hat minus P over the square root of PQ over N. Then put numbers in those spots. And you get a Z-score. To turn that Z-score into a p-value, what calculator function do I use? Normal CDF. Why am I not using T-CDF? Z is normal. So normal CDF, and then you're going like low to high. That's the p-value. You're always going to sketch a graph where you're putting like P hat, Z in your shading. And if it's a not equal to test, what would you do? You'd shade both sides. So hopefully a lot of this is just like, oh yeah, this is the same, this is the same, feels familiar. We're like keeping the bones, we're just plugging in different spots along the way. Questions yet? So your conclusions, I'll write them both. I'll write both the possibilities there. So it could be, oh yeah, we should write alpha somewhere. So alpha equals whatever. You can put that anywhere. A lot of you guys, when you did the test, you just put it like right up at the top here. Totally fine. You don't get what?
It's not really getting good. This Jesus fish thing. It's like real.
So your options are, since P is less than alpha, since P value is less than alpha. In that case, we would reject H naught. There's not enough evidence. To support HA.
Wouldn't there be enough evidence if we reject H naught?
Oh crap, yeah, there is enough evidence to support HA. Thank you. Sorry. Since P value is less than alpha, we reject H naught. If we're rejecting H naught, there is enough evidence to support HA, meaning we think HA is true,
We can't see that.
but put in context. No, you can say that.
There's no one
So yeah, we
saying meaning HA is true. You have to say meaning
You can't ever say HO is true. That's what you're thinking.
You say it's not.
you reject
Right.
or fail.
Right. So that'd be one version of the wording. There's several of you that are not getting the wording. Like when I read through your tests, and I think you know it because you graded your own. That wording doesn't go away. Like every one of those tests back there on that board, it's got that wording, and that's like half the AP test. It's going to be like half the tests that you take next time that could replace your old grade. That wording is huge. So if you're not getting it, take some time and memorize it. second option here would be since p-value is greater than alpha, now we fail to reject HO. So if we're not rejecting HO, it's because I wasn't impressed by HA. But I wasn't like, oh yeah, that must be right. So there is not enough evidence to support HA. Meaning we don't think HA is true, but put it in context. And so every one of these you do, that wording, that process stays the same. All you're doing is basically like that sentence, the first two sentences will stay the same. All you're doing is putting it in context, really. If you just memorize these two, just understand what they're doing, you can literally write word for word up until you get to the context part of both of them. Questions on the template or anything so far? All right, try number 2. Can you guys read up this guy? How about feet?
Marty, you want to move the table?
Yeah, it's encroaching. Thanks.
Not feel so far away from the board.
I feel far